everyone. Welcome to the Product Design and Manufacturing. I don't know if it's the show, the podcast, the post. I don't know what it is. So this is my first one, and tonight I have another nomad, Tabor, and she is a mechanical engineer.
Yeah.
Yes. Go ahead.
So currently I'm the hardware lifecycle manager at Carbon, but I was previously a design engineer and then I got promoted.
Oh, fantastic. Well, one of the things we're going to talk about tonight is I've been a customer and a user of 3D printing for many, many years. I made I'll be doing a story on how to finish this. This is printed on an FDM machine from Stratasys. It's a F370 and it's ABS plastic and it's really easy to work with, but this is the kind of thing I've been doing for 20 years. I've been using these machines, and everything's changing, and I'm getting a lot of questions about, what's a good machine to buy. And when you and I started talking, I don't know, probably last week about things, I wasn't even aware of your company. So, so I went and trolled you, of course, and looked at all. I found you on LinkedIn, and I just followed the trail.
You should connect on LinkedIn then.
yeah, we should. I did, honestly, I'll be honest, I did it tonight because I did the copy clinic this week, and my mind is it's still melted. It's really good. But the materials and things that we had talked about, you were making actual products that could be used.
Yeah.
So when I'm doing things like this, I'm making prototypes, and they're wonderful for prototypes. I'm in the motorcycle industry, and we can fit parts. We can, do real complex things. We can, test for undercuts and manufacturability. But this is not as strong. It's about 70% as strong as the same part in injection molded plastic. So like for our die cast parts or our forged parts that we manufacture, we can see if it fits with this, but we can't actually test it or use it.
Yeah.
So one of the things that you had talked about is actually printing materials that are usable. Could you tell us a little bit about some examples of that?
Yeah, so the Carbon technology was specifically made for end-use products to kind of skip out that prototyping stage or to have more functional prototypes. So the material, we do a wide range of materials. In contrast to the FDM, we don't do the thermoplastics, we do thermoset plastics. That's due to the chemistry that's needed for our printer to work.
And let me just jump in right there. So the difference between thermoset, and correct me when I'm wrong, I'm a product designer. She's an engineer, so usually we'd be all at each other because we design something and then then I
have to go make it.
They have to go make it. But anyway, the thermoset versus thermoformed, like thermoformed plastic is how they make something like bed liners in trucks, where they heat up the plastic, it melts to or it softens to a certain thing, they vacuum form it, and they could actually do that same piece over and over again, because once you can heat it more than once and it'll deform. So thermoset plastic is more like what was used in before World War II, Bakelite and things like that, where you'd form it once, and once that's that. Like if you've ever smelled plastic burning that has that weird plastic burning smell, usually that's the thermoset plastics. They have a really distinct smell.
It doesn't melt.
Yeah, they burn.
Yeah.
So anyway, you can do thermoset and you can do thermoform, but I just let people know what the difference is.
Yeah. So our printer only does the thermoset plastics, but all our formulations have been done such that we get isotropic properties for when you apply stresses in any direction. It's uniform in X, Y, or Z.
That's incredible. That's incredible because again with this,
right.
You
get the layers.
Yeah, you built in the layers. It's hard to see, a little bit hard to see, but you get the layers in here, and like the layers right now are going this way. I built this flat, so the layers are going up, so I can bend it like this, and it's really strong. But if I was to able to peel it this way, I could peel it apart, and it would come apart like a pastry.
Right. So microscopically, you can cut a cross section of one of our parts, and you wouldn't necessarily be able to distinguish the layers if the print parameters are set properly.
So what are the this one? Our machine, I describe it as, it's basically a roll of fishing line that goes up through a little heater that heats it up, and then it gets drawn through where it reduces its size from like a 1/16 of an inch piece of plastic rod down to a or filament down to, we can get down to 5/1000 of an inch, I believe is what our best one is.
Uh-huh.
So looking at what you guys were doing on your website, at Carbon website, I was
Yeah.
absolutely amazed at the detail and the level of stuff you were getting, because we can't get that with our machine. And so
Yeah.
looking at that as a production, is it deposited? Is it laser cured? What's the process, or is there
No,
different
so
processes?
it's totally different. So we call our process DLS, for digital light synthesis,
Mm,
as opposed to FDM, which is fused deposition modeling.
right.
There are a few others. It's the broader category that people put it in is DLP
Okay. Yeah.
printers. Um, but ours is a little bit different, and of course, marketing. We
Mhm.
branded our own thing. And the process that DLS uses is called CLIP, for continuous liquid interface process.
Okay.
And so the way our printer works is you take the plastic resin and you put it in what we call a cassette. And in the bottom of the cassette, there's a window that lets the UV light through, which allows you to cure the resin into its harder form, its green form
Okay.
in our case.
So it's a UV,
And
is it a UV laser or just a UV light, or how do you?
it's a UV light
Mhm.
that goes through a projector, and it projects the cross section
Oh,
of
okay.
the
Yeah.
entire layer at once.
So like on
Yeah.
the old, stereolithography, when, I mean, actually 30 years ago, I started messing around with stereolithography. That was really the first
Mhm.
3D printing. Then
Yeah, so stereolithography does the laser drawing.
right. It draws a layer at a time. So this is
Right. So we
actually
don't do
shooting
that.
shooting
It's
like
the
a
entire layer
picture.
at once. Yeah.
Wow. Wow. Oh, I can see how that would
And
be nice and strong.
then in addition to that, the window also lets oxygen through. And so the key thing for those thermoset plastics is that oxygen inhibits curing.
Mhm.
And so the part never cures to both the platform and the window.
Right.
And so that allows you to print faster, and you don't get layers between each, what we call them, slices,
Yeah. Yeah. Right.
because you don't have to stop, peel up, and then go back down,
Mhm.
which is how the SLA process works and other DLP processes work.
Right. Right. So
So
that, like
so we don't have to do that step.
Oh, that's amazing. Because the SLA process, what it basically, for everyone out there, it's stereolithography. What's the A stand for?
It's just an abbreviation for
Just so it's stereolithography. I know what the A stood for,
Yeah.
but anyway, so it's basically, to simplify it down to really easy, it's a vat of urethane that they shoot a laser down into. The laser is on a it's either a programmed or on a track. The old ones are actually on a slider, and it shoots a laser down, and basically, if you think about building something up in a layer by layer, each layer, it does an outline of the layer, or fills it in, but the laser actually moves through this, and it cures that layer. And then the platen that it sits on sinks down a certain amount, and it does another layer, and then sinks down a certain amount, another layer, and they all kind of bond together, and you end up with the
Mhm.
part that's really pretty cool. But it takes a lot of after work to make it
Yeah.
attractive. And like, if you took it like this, I say it was a straight thing, and you held it against a wall like this, it would eventually sag and bend. It's not very UV stable. It was very expensive. We did some stuff in the 90s, and we did a primary for a motorcycle, which is about a foot long, maybe 8 inches tall. It was $9,000 for this one piece. Maybe it was 2 inches
Yeah.
deep, but that same part today can be made for a few hundred. But anyway, that's one of the other styles. So I'll let you
Yeah.
keep going with what you're talking
Well,
about.
I could probably talk about all the different styles, but yeah, focusing on the carbon one. So the layers are uniform. The detail quality is determined by the pixel size.
Okay.
And so I believe our pixel size is 40 microns.
Really?
Yeah,
Wow.
it's pretty tiny.
That is teeny.
And you can get better detail because you can do grayscaling, where the light flashes on and off. So you can only get like partial curing for that pixel.
Oh, really?
And so that's
So what would you use that for? For example, what would that, to partially cure it versus fully
so
cure it?
So one of the biggest industries that uses 3D printing, like as a just overall part of their process, is
Hmm.
dental. Dental is the
Right.
biggest user of 3D printers.
Yeah, that's true.
Invisalign, they print every single mold for the teeth, and then they they vacuum form the aligners on top of those 3D printed teeth.
While we're talking about this, I've got the website up, so I'm gonna do a share a screen here so people can kind of see. Maybe you can explain a little bit. So the dental stuff that we're talking
Yeah,
about.
so dental also makes it pretty tricky because like the accuracy need is very, very high.
Right.
Like because you can think you know you get something stuck in your teeth and you feel like, oh man, this thing is huge,
Mm-hmm.
and then you pull it out and you're like, damn, that was small.
A little teeny thing. Yeah, yeah. Piece
It's a
of
little tiny
the
thing,
end
but it
tip of a
causes
piece of
like
fennel seed. Yep.
it causes so much discomfort.
Mm-hmm.
And so the grayscaling thing is needed to hit the accuracy for dental. It's not necessarily needed for everything, but we built it in.
Oh, I see. No,
Um,
that makes sense.
yeah. So so yeah, the first big product that we really had announced that we were a part of was with Adidas.
Okay.
Um, so we design and build the printers, and then we lease them out to whomever. But then we also work with a lot of companies to help them design products using our process.
Yeah, that's cool.
So
I noticed that when I was looking through as as a business guy, we bought our Stratasys
mhm,
F370. We traded in, we had an old Dimension machine, and I've been using the Dimension machine since 2002. But we got the new one, and we bought it, but like I was reading on your site, I'm like, well, you can't buy them, but there's a subscription service.
yeah,
And at first I'm like, why would anyone do that? And then as I read through it and I started thinking about it, I'm like, we spend thousands of dollars a year just on maintenance, on a maintenance
mhm,
package to make sure that something happens. Now, I will say Stratasys, they're a local company, and they build a good machine. Um, but it requires some maintenance. And I
yeah,
was I was reading through what you guys do, and it's kind of like when Adobe went went to a subscription service with Photoshop and
mhm,
Illustrator and all of them. I remember what that happened. The company I worked for at the time, all the people in the design room they lost their minds because they're like, this is going to be
yeah.
crazy. And to me, I'm like, this makes the
I
most
lost my
sense in
mind
the
when that
world.
happened too.
Yeah, yeah, yeah. So I just spent $900 on Photoshop. Now you're gonna give it to everybody. Oh, so I like the model. I think the model, the business model of this is a really interesting way of doing it for somebody that
Yeah,
has has a need to make a lot of parts, to have the company have your full service, all your updates, everything's
mhm,
included in this one package a year. You guys can, I want you to just go, it's carbon3d.com. Go check out their website if you have an interest in this. It's really cool stuff, and the website's a nice it's a really well done website too. But anyway, um
yeah,
it's expensive, or it sounds like an expensive thing to do year to year, but coming from me, when you get a 3D printer in house that's good, that will reliably build stuff, you will use that like a microwave. You're not going to know how you lived without it, and it is constantly running. So yeah,
yeah.
with that, we can go back to the Adidas thing, but I wanted to bring
Mhm,
that up, the model of what it is, and let people go to this website, carbon3d.com. It's really worth looking through. So let's get back to the Adidas story.
yeah, yeah. So we've been working with Adidas since I think 2017, and they've been really big on wanting to have 3D printed sneakers for a long time. Um, and so we were able to make that happen. And so they're on the market now. They have been for a few years. They've really come down in price.
So that's you guys that made those.
Yes.
I mean, we remember when they came out, we're all like, oh, look at that. Oh, I got 3D sneakers.
Yeah. Yeah. So they're called Featurecraft 4D.
Yep.
We actually have two different versions now. And so the original just has kind of like a triangular lattice.
Mm-hmm.
And then the new ones, they're called 4D Forward. And so the mesh that's in there is specifically aimed at runners. And so as you're running, when your foot comes to hit the ground, instead of just compressing straight down, it actually compresses and moves you forward at the same time and pushes you forward.
So it gives
You
it a
get-
little bit, you get a little bit of spring action out of it. So as it
Right.
compresses, you can spring it.
Right.
So,
Right.
and
And then specifically it pushes you forward, not up or back.
oh, okay. So yeah, that makes sense because you wouldn't want to have push up because then you're actually fighting that force to go forward.
Right.
That,
So we were able to design a lattice to make that happen. And it's printed using carbon printers.
and you're talking about the price went down, do you have an idea what the price was? I should have it up on screen,
They
but
when we first started selling them, they went on the market for about $400 a pair,
Mhm.
somewhere in there. When they were first like announced and like sample pairs were handed out to reporters and stuff,
yeah,
those went for sale on eBay for like $1,000.
yeah, I remember that. It was crazy, and they
Yeah.
were selling at that too. People were buying them. They were snapping them up.
Yeah, it was nuts. Now I believe they're $180.
Yeah, see, and
So
that's
it's been a
right.
significant price drop.
I mean, and that's what
Yeah.
that's what I pay for my regular sneakers, and I could get a set of 3D printed sneakers. Now I feel like a fool. Um, the so what kind of the problem with 3D printing that I know of is that I can print one of these or I can print a stack of them or whatever, but the compared to an injection molded part, now granted tooling and stuff, that's something, but if
Mhm.
once the tooling's done, an injection molded part compared to this, injection molding is much faster. So, but
Yeah.
there's been such huge jumps in production. So like for the shoes, like you're talking about, to be able to retail those for $180, you need to be able to make those
Mhm.
pretty quickly in numbers. How does that
Yeah.
work? Or maybe you can explain
So
some of that process.
so our print process is actually very, very fast also compared to most FDM models.
Okay.
Um, uh, the print time for the shoes, I believe, is about 26 minutes.
Well, that's not bad. It's not bad
Um,
at all. That's a lot
it's
faster than
probably
making them.
it's probably a lot faster than that now. The the program has evolved a lot since I was directly involved in it, but at the last point in time when I was like highly involved, it was 26 minutes to
Well, and
print.
to give you an idea, this was 2.5 hours. And it's, you can see the size of my hand. It's about the size of my hand, and it's about, half of an inch tall with some detail, but nothing really spectacular in there. It's just a pretty easy thing. That was 2.5 or 3 hours for this. So in that time, you could do, 8 pairs of shoes or whatever. More than that. That's math.
Yeah. So the large format printer does a pair of shoes in about 26 minutes. And after it's printed, because our print process is so fast, we're able to use resins that cure on their own.
Oh yeah, you would be able to, wouldn't you?
So basically, the way our dual cure resins work is that you print them to set the shape and then you bake them in order to set the properties.
Okay.
And so then they go in an oven to cure at a specific temperature to set the elastomeric properties.
The oven, is it just a
So-
regular heat, or is it a vacuum chamber?
So they use an inert oven for the Adidas process.
Okay.
Not all of our resins require an inert oven, but we do have if you're interested in actually getting a carbon machine set up,
Mhm.
we do have recommendations for the different ovens that are involved.
I know
Um,
I've done some carbon fiber. I actually did quite a bit of carbon fiber design and fabricating in the past, and we needed an autoclave to really cure it to
Mhm.
that real thing. And I was just curious if that was
Yeah.
the same.
Adidas developed their own continuous run ovens. So the curing process is about 8 hours in an oven for their resin,
Wow.
which is long, but it continuously runs, so it's not terrible.
Right.
Plus, it turns out so the Adidas Boost is what they're called. So a different product line, one of their other high-end product lines, use the same cure time.
Okay.
And so for them, that wasn't a huge deal breaker.
Right. Yeah. Oh, it's
They're already
interesting.
kind of set up for that.
Well, and
So
go ahead.
So yeah, our different resins have different cure times. The Adidas one is one of the longest. We have others that are 2 hours for that cure. But yeah, our print times are really speedy. That was actually the way I heard about carbon in the first place before I started working there. Our what our co-founder and CEO at the time gave a TED talk, and the title of the TED talk was "What if 3D printing was 100 times faster?"
Yeah.
And so as he gave the speech on the TED talk stage, we had an early prototype printer printing at the same time, and it finished a part in the same 10 minutes that he gave the speech.
Wow.
So I saw that and I was like, oh, that's a cool company. And I didn't know at the time I'd end up working there, but here
Oh,
we are.
that there's so much happening in 3D printing right now that people think it's brand new, but it's been around for quite a while. I remember
Yeah,
going to,
that's actually an interesting thing, right?
yeah,
It's been around since the early 80s. So
right.
it's like 40 years now.
Hmm.
And I'm pretty passionate about this, much to the detriment of carbon. But part of the reason why it took so long for 3D printing to really become a known process and start to be adopted was all the IP around it,
Right.
patents. Like it wasn't until the first patents expired that we really got to get competition with 3D systems and
Yeah,
strategists.
that's right. That's right. And I've been to my first real introduction to, I like I said, I'd done it in the 90s. We've used it for product development in the 2000s. But in 2003, I went to the SEMA show in Las Vegas. It's a big the automotive aftermarket. And that was a 3D print. Every year that's a 3D printing mecca. They have a whole room full of 3D printing people. And I could not believe the different kinds. There was FDM, there was the SLA, they were just starting to play with carbon stuff, but that was like spaceship things back in 2003. And then there was the sintering. So sintering was,
SLS.
yeah, SLS. Yep. So, and that was really interesting. And, you go to these things, and then they had the scanners there too, because you have to, if you want to print something, you need to have to do it. So all the scanners came in, and like we 3D scan every motorcycle we get. So we'll get a new Harley Davidson, and they change the front fairing or something like that. So we'll 3D scan it. So we have that in the computer. So as we make parts to fit to it, they fit exactly to the contours and things like that. There's no more measuring with slide rules or anything like that going on. It's all done in the computer because it's way faster. And so you go to this thing, and they got a guy there scanning a model of a PT Cruiser. It's 2003, so those goofy little cars. He's scanning a model of a PT Cruiser. He's got the big screen over here, and you're seeing this model appear on the screen. And I know, I'm like, this isn't even anything that's usable yet. This gives you a point cloud that's nothing. Someone has to still go in and do it. But the way they were presenting it at this show is, I can scan this thing in here, and I can print it on that machine right there. And they were doing it, and it was really incredible to watch. And then we tried a bunch of this stuff. We'd send out files and have it made. And sintering was nice because they could do metals. So some of the stuff we wanted to try with our die cast parts and flow. And so we had some like intake manifolds and things like that. So we'd send them out sintered, and they come back, and anything that's a circle was an oval. It just, the technology wasn't there yet. And we couldn't get the shape, and the FDM worked really close for that. And we didn't need the heat properties because we could just do flow bench testing and stuff like that with plastic, and that would be the same in aluminum. So we ended up with that machine. But seeing all the different ones, so I went to SEMA in 2003, 2007, and 2014, in the leaps forward in those years. And I didn't go this year, but it's going on like right now, or last week it went on. But the leaps forward like this, like companies that are, I'm looking at your company, and this is a big place. This is a major deal that I wasn't even aware of, because I'm kind of, you get in the Stratasys.
Yeah.
We're in that deal. But, looking into this, soft goods, some of the silicone, I've got the website up here, so I'm looking as we're talking. I'm not ignoring you. The silicone soft touch, biocompatible and tear resistant. You have a picture of like, it's either it's an earphone. It looks like an earbud. That's fantastic. Our machine does some rubber parts, but it's touch and go. Whether, again, it's just rough prototype things. But these parts, these photos here that are on the website. I'm on what page I'm on here. One of the consumer, the consumer pages. And there's a pedal for a bicycle, it looks like, or something like that, that's made out of the rigid polyurethane. And then there's a like a midsole, a saddle, or a sole for a shoe that has a bunch of cross. I'm talking like this. I'll just share the screen. Hold on a second. I will share this screen so we know what we're talking about. So Here we go. Share. So as you see here, the one on the left is the silicone soft touch biocompatible tear resistant, for wristbands or earbuds. What is that, a carbon too, or what is that a different, that's a different, or what is that?
So we've developed most of these resins that you can see on our website. Sil 30 was one that was developed in-house. So the part that's printed is that the dark gray that's on top of the earbud.
Sure.
Yeah.
And so that would be a soft rubber or silicone kind of feel.
Yeah, it's kind of squishy. It's actually one of our hardest resins to print.
I bet. I don't know how you do
really,
it.
really delicate. So it prints fine. The challenge is then getting it off the platform.
Without tearing or without I gotcha.
Yeah.
And then the next one, the rigid polyurethane. This is something that I can see our company would have a big use for.
Yeah, so that's our bread and butter right there is RPU. We've had a ton of different formulations. This RPU, I in particular love using it for air ducts.
Oh, okay.
Because you can build in louvers and things with the 3D printing process.
Yeah, you would be able to.
It would have to be multiple parts in any other process, but you can really do some cool stuff with 3D printing.
That leads me, because
RPO is probably the closest to like your standard performance plastics that would be injection molded.
Sure. Yeah. One of the products that we manufacture is a phone holder for motorcycles, and it's a glass filled nylon that's also inset molded rubber. So the rubber fingers hold it. Yeah, I don't think I have one. I don't have one around here, but that would be wonderful for that to try out some, because we could take that and we could mold it in. I could use that as a base for a mold and then over mold it with different kinds of silicones just mechanically to test different things. I know there's one
of the other things that you can do with all of our polyurethanes is that you can co-bake them together, because the polyurethane structure will fuse together.
That was my next question.
So you can print the two parts and then put them together and bake them together, and then they become one part.
Wow, that's incredible. Yeah, because it seemed like that would be something that was possible. And so now on the next page over, it's got the picture of the green kind of shoe.
So that's the Adidas midsole. Yeah.
And is that a lattice? That's a lattice work inside. So this is something that it would be impossible to manufacture. You can't manufacture it. You can't cast it. You can't stamp it. You can't do anything because it's a lattice work inside of itself, a honeycomb.
Yes.
This is where 3D printing really, really excels, because you can create things that are not manufacturable. And if you're telling me that you can manufacture this in a reasonable amount of time, this is world-changing technology here. So tell us a little bit about that.
Yeah, so like you said, the lattice structures, the only way to truly manufacture them is with the additive manufacturing 3D printing. So yeah, the shoes were what we targeted first, but really anything where you use foam is a good candidate for a 3D printing replacement. Some of our other products so you can see the green midsole, that's the one that's in that next picture.
Sure.
Some of our other products that use the lattice would be the helmets that we do for Rydell. They're football helmets. And so they have a customized lattice where they scan all of the players' heads.
Cool. Yeah, I've got it up on screen right now. It's got the little spinning icon.
Yeah, so there's a ton of different lattice structures that are all aimed at supporting different types of forces that would hit the helmet at that particular point. So you can see how the lattice structure changes. You can't really control that kind of thing with foam very easily, but it's very easy to do with 3D printing.
Yeah, with foam, I had in one of my previous careers, one of the things I did was I airbrushed goalie masks. So, the goalies, they got all the crazy painted stuff. I was one of the guys that painted that stuff. Well, we'd always have to rebuild the mask after we paint it because you don't want to get all those paint fumes and stuff in your foam. So we were always putting all the different foams inside. What you're talking about is exactly right, because we'd have a different foam in the front for the forehead than we would for the back of the head, because this, and it was a huge pain. And I'm looking at the picture here on as this helmet spins around, and you can see how what the back of it has a much more open
Yeah.
open source, so that probably that would take less of a blow, but have more of a cushion, where maybe the front stops the impact a little more. I'm just guessing at this, but you can, anyway, you can just see the differences in the densities of all the material inside. So does that have to do with the spring of it too? So that okay.
Yeah. And the other cool thing is, because there's no tooling involved with this really, they're all customized to the players. So it's
sure.
customized to their positions that they play. It's customized also to their heads. So it fits really well.
I suppose, do you get a scan of their head, or some
Yeah.
3D model of
Yeah,
their head
so-
and fit to it?
So what Rydell does is they scan all the players' heads, and then they have some software that will then import that into the model and tune that lattice to work with that player.
That's amazing. I mean, that
So
in the again, in the motorcycle world, instantly I'm thinking of motorcycle
Yeah.
helmets and the different things you could do with that. I know that there's been,
well, I think
Oh.
that's kind of how we connected on the
Yeah.
Nomad Network.
Yeah, we were talking
because I
about-
saw the helmet.
yeah, that's right, the helmet. I should grab that and show it before the end here. It's in the other room. This is my first time setting up. This is my first new wall of, I don't know if it's a podcast or show wall, but it's something I put together. So I did leave that in the other room, and I meant to grab it before. And as soon as I sat down and get started, I'm like, oh, I forgot the helmet, but I can show that towards the end here. But yeah, that the possibilities for that are just really incredible. And bicycle helmets, I saw that there was a bicycle helmet. Let's see,
We also
bicycle
do,
seats.
the
Seats. That's sort of,
seats.
yep.
Yeah. And then at one of the 3D printing trade shows, we recently won an award combined with Erxler, who's a manufacturer in Germany. They work a lot with Adidas.
Okay.
They did a seat design for Porsche using actually the exact same material as Adidas. That's one of the things that brought the Adidas cost down, is that anyone can order
Oh, sure.
the same
Yeah, that,
material.
yeah, make it. And is it that material only work in your machine?
As of right now, yes.
That, I would say that's good. That's good. Let the material be available, everybody, but make them by your machine. That makes sense to me.
Yeah, so
I'm
the
looking.
the EPU is a really cool material, because it really lets you get like a true elastomer printed, so you can stretch it without worrying about it tearing.
The EPU, and that, which one is that? That's
That green. It's the green one.
the green
We
one.
have it in
Okay.
both black and green.
Yeah, that's really interesting. Yeah, so the future of this, one of the things, so we get an idea of what you guys do here. I'm going to get out of the screen share here. Again, go check it out. Zero 3D. That's my website, carbon3d.com. And they've got some really neat stuff on there. I would like to now kind of shift a little bit from that into another reason I think 3D printing has gotten so popular is the whole MakerBot revolution. And these home printers, we've looked into a lot of them, because there's always, we think, it'd be nice to have 2 or 3 more printers, but we don't want to spend $50,000 of time for it. And maybe we can look into some of these less expensive ones, but for home crafts things and for something like the artwork and sculpture that'd be fine. But when it gets down to the minutia of actually trying to make parts and products and prototypes, I found anyway, the $1,500 machines just aren't up to, they just don't have the what do you call it, the accuracy needed to really make it. But they're fine for doing crafts and signage and some other things like that. So what's your experience, or am I wrong? Because I could very well be wrong. With the less expensive ones.
It kind of depends what you're going for. Those home printers, they tend not to be very repeatable. I think one of the common pain points that I've experienced with the home printers, and I think a lot of people probably probably also know from the home 3D printers something called the spaghetti failure,
Yeah. Yeah.
which
The
you've
rat's
probably seen
nest.
it.
Hmm.
Yeah. So that tends to happen much more with the say MakerBot
Yeah. Yeah.
printers. It basically comes down to when you're designing a machine for a hobbyist, um, you have that lower price point because again, as cool as the carbon printers are, it's generally not something you're going to use as a hobby in your garage.
Right. Right.
It makes sense for a business, not as the hobbyist
Hmm.
necessarily. Um, and so the effort that they put into putting that machine out to market is placed on the price point as opposed to that precision
The
and
precision and
repeatability.
quality. Exactly. And it's
Yeah.
changed. Like when we had our first Stratasys machines that we bought in 2003, we bought two of them, and they were just the Stratasys Dimension machines, the BST, and it printed. Now they print this. You have a sheet of plastic that it prints down, and it prints on the plastic in a heated environment. Blah 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 blah. Back then, it was still a heated environment, but we were printing on foam, like inch thick squares of foam that were the messiest, itchiest, most awful things. And then we'd because they were also expensive, so we'd take the foam, you'd use it, and it was, I mean, it was almost like the Oasis stuff that grandma used to make, put her
Okay.
flowers in.
Yeah,
It was
that's
it
the
was it was
floral
that,
foam.
yeah, that same kind of texture, and you'd slide in the machine, and it was expensive. So what we'd do is after we used it a few times, there was some divots in it, because you could tell it to print in a
Mhm.
different place. I got a fly cutter and put it on the milling machine, and we just run it back and forth and do with the fly cutter on the milling machine. It would always go up and reset to itself. So we'd use the same piece of foam 10 times. Well, by the eighth or ninth time, the little sliders that you slide the foam in, those have moved a little bit. So parts start, and then you get that rat's nest. You come back in the morning, and your part that was building for 12 hours is junk.
Yeah.
But
Well,
they've
that's the other thing is those home printers are also very slow.
right, right. And that's where, when this came out, when this FDM stuff, we started using it, it was like lightning to us. I mean, it was just like lightning, because we were and this was a different company, but we were spending $20,000-$30,000 a month on prototypes, SLAs. And so for $29,000, we could buy this FDM printer that the cartridges were $300 a piece, and they'd last, a month. Well, this just made perfect sense. I mean, we paid for itself in 2 months. It was paid for.
Mhm.
Plus, we had five times the amount of output, and it didn't take a week every time you needed to do something. And so that was a really good thing. So the MakerBots, the home printers, they're good for some things. I don't tell people to not buy them, because you can do a lot of fun stuff with them. But just know that it's not going to be
Yeah,
like
absolutely.
it's not Star Trek where you're printing out something that's just going to work. You're going to have to do some stuff to it.
I would say if you're prototyping stuff with it and you want to test with a home printer, they do much better with compressive forces than they do with tensile forces.
Right. Like you could push down on it or clamp something together as
Right.
a spacer and get a better idea. But if you have to pull it, it'll just come apart. And even the higher end printers have the same problem when you get to the FDM and things like that. We soak it in solvent and infuse all the infuse
Yeah.
all the layers together. But one of the nice things about what you guys are doing, and some of the other companies do it too, is that you don't need to buy the printer. You don't need to spend the $5,000 a year for it or something. You can send them a file and you'll create parts.
Yeah. So we have a lot of kind of production houses that Carbon has partnered with. They have a bunch of our printers, and you can request the Carbon process.
So as in the nomad
Yeah.
spirit of things here, this is a whole cottage industry of people that go out and they buy a bunch of printers, and then they basically you advertise yourself, you market yourself as you have a part, we'll print it for you. And our company, we're a design firm. It's Ciro is our company name, CIRO, and we're a design firm, but we just happen to make motorcycle parts and accessories. But we also have done design work for other companies all over the world as kind of a silent partner kind of deal. And it's the same thing like that, where the person doesn't have this company might not have a design team to design a product. We do, and we can manufacture too. So it's a unique way. But we also have 3D printing, so we can 3D print. But we do use those because we don't have the capabilities to do everything. Like most of what you talked about tonight, we can't do in house. We can make this. which is great on a lot of levels. But a lot of times we need to have something else. There's some things we're working on now that have the airflow issues that we need some silicone kind of tubing parts made that you can't manufacture. And we could print one. And I'll tell you the way I do it before. We'd print one. I'd take it to I have a home shop. It's an auto body shop basically at home. And I do finish work on it to get it perfect. So it looked perfect. A lot of priming and sanding and painting. And then I would take that piece there and I would make a mold of that. And then I'd pour, I'd make a silicone rubber mold of that. And then I'd make a urethane, 2-part urethane pour or epoxy pour in it to get a hard part that was usable. Well, that's a long way to go when we could have just sent you the file and, a week later, whatever you get it, you'd send it back. I think that's a lot of people don't realize they can even do that. And the maker space, a lot of the makers, the guys that are just making stuff, and they're the ones that have the maker bots and the other brands of the lower cost, home ones. When they get to that level and they're like, I've talked to a lot of them, like, well, why don't you just send it to one of these companies that prints it for you? You'd be surprised how reasonably priced it is, depending on what you're making. I mean, of course, but and how many, if you had to make one shoe for Adidas, it wouldn't be $180 or a half of that, it wouldn't be that at all. It would be multiples of that. But for a lot of the parts, like I think of like a chess set, if I wanted to, it's one of the things I'm actually working on is a chess set of little tiki head guys. And so I'm sculpting them, and then I'm deciding after I'm sculpting them, do I want to build this in the computer? I don't want them to have that computer made feel. I don't want to do them in SolidWorks is the program I use. And I feel like if I do it in there, it's going to be way too easy to just mirror one side and the other. When I'm sculpting it, you can get those idiosyncrasies of the design itself. So I can take that and scan it, and then I could send it to you guys for and we could do one set, we could do 5 sets, we could do sales samples. And I see that reflected in the website, and people, they think 3D printing, they don't know exactly what to use it for, but sales samples is a big part of it.
Yeah. Well, and in general, one of the cool things that I've found about 3D printing is just how much manufacturing it's opened up to the world. Like, I know people who are interested in 3D printing that never would have been interested in mechanical engineering, for example. Like, make that part out of metal, they wouldn't care. But you can do this at home, then suddenly they're interested. So it's really opened up that world of manufacturing. But at the same time, there's a lot more behind it that is a whole new world also to explore, where you do see this with other manufacturing techniques. Right. Like our printer happens to use a lot of sheet metal.
Okay.
Like any machine would.
Right.
But we don't make those machine parts in-house.
Right.
We go out, we buy them, then we assemble them.
Mm-hmm.
And the 3D printing would be the same way. It's really becoming that kind of process where you can send it out to a 3D printing house, and then they send you the parts and you can assemble with them.
Exactly. And those houses are growing all over the country. I mean, there's people all over doing it. I don't know how many you guys have, but I imagine partner wise with the way that you've structured your business.
We do have a list of them on the website.
Oh, do you? I wonder.
Let's
see. Let me see. Resource library, ask and export. Let's see. Get parts. There we go. Dental lab locator, carbon dental partners, carbon production partners.
Production partners.
There we go. I'll click on that. I'm gonna click on that and I'll share the screen again so people can see it if they're interested. Share. So here we go. Get your next product produced with the carbon DLS process. Yeah, okay. How to become a partner if you want to do that. Production partners. Oh yeah, so this walks you through it right here.
Mm-hmm.
That's fantastic. How great is that? Again, what we're doing all here in this Nomad network is exactly what the 3D printing world can offer. So you can build a nomadic business, even though you're in a brick and mortar store, but you can put it anywhere. If you have an internet connection and electricity, what kind of power does these machines run? Or what do they need? I'm sure I should say that. What do you need to plug it into?
So the smaller printer is 120 volts, less than 20 amps, I
Wow.
believe.
Plug it in a wall.
The larger printer does have special requirements. I think it's 240 volt, and
Okay.
I do not remember the current requirements.
Sure.
But
But for a
the large
business,
printer is pretty substantial.
yeah.
It would be reasonable for a business, but yeah, not for your garage.
Right. Well, and I've got, I think you will find people will build them in the garage. Does Jay Leno have one of your machines? I know he has a whole bunch of
I don't
different
know.
companies' machines. That'd be fun to find out. But to
It
do
would be news to me,
220,
but
220 or 240 in a regular garage is fairly common. I mean, my air compressor runs on 230 volt, a 230 volt, 30 amp, fuse. So to do something like that wouldn't be out of the realm. A hot tub, your dryer runs on that. Your
oh yeah, an
electric
electric dryer would. Yeah.
electric stove would too. So I mean, you do have that power, but like you said, it's probably more than someone would need for their home. But if you're building a pneumatic thing right at your house and you have a reason for it, you've come up with a good idea, and you can, you make some clothing. I know that the clothing industry and shoes, bags, accessory industry for 3D printing, the 3D printing style, the layering of it has actually become a look. It's become a finish that people understand. I've noticed that over the years of taking prototype parts to motorcycle shows. We'd have some prototype part on a Harley 10 years ago, and it was that same kind of, we used a gray color because you could see light and dark in it. And we'd show it to somebody and they'd look at it and go, well, I don't want this, got lines in it and it's gray. And no, we're like, no, it'll be chrome when it's done. This is just a prototype to show you. What do you think of this? And they didn't understand what it was. Well, you do that now and they're like, is that 3D printed? Oh, that's so cool. So now it's a bonus to show this unfinished thing because people are like, wow, you guys are really at the cutting edge if you have a 3D printer. So it's still in its beginning. But anyway, that was a good kind of overview of what you've got going on there. And you're the designer of this.
So I have been involved with every one of our products that has been on the market.
Excellent.
I can say I've designed parts that go in all of those things.
How big of a design team do you guys have? Design or engineering?
So our hardware team is about 15 people right now.
Cool.
The entire company right now is about 400 people.
Wow, that's big.
When I first started, I was hire number like 55.
Really? Oh, yeah. That's excellent. So you've really watched the growth happen.
Yeah.
That's exciting.
We were at over 100 within less than a year from when I was hired.
Wow. So we've got, we started our company with 5 of us and now we're up to 15 and it was 7 years. So that kind of growth that you're talking about.
We had venture capital behind us.
Well, that's good. And an exploding environment to bring out, and you have a great product. I'm looking at this and I'm just amazed. And I always wonder I'm like, how do they come up with this? How do they make this? And I'm a designer. I do product design. I design lighting. I design, I do some engineering as well, but I look at this and this is such voodoo to me. It just amazes me. So the fact that I'm talking to someone that actually does it, I'm fangirling a little bit. I'm pretty excited about this. So I'm glad you were able to come on. This is really cool.
Well, hey, I'm happy to come back anytime and talk more. About any of these details too. So
this is great. I was figuring that we could go a half an hour. We're almost an hour in right now. But before we go, the other thing I wanted to talk to you about, and this is outside of everything. This is your seasonal market finds. The
produce pack.
Yeah, the produce pack. Tell everyone in the network a little bit about that, because this intrigued me too.
Totally different side project.
Yeah, this is nothing to do with 3D printing. This is nature.
Nothing whatsoever.
Yeah.
So I've always been a huge farmers market attendee. That's like when I'm looking at places to live. That's like one of the things that has to be there. Basically what I've started this website to do is there's so much seasonal produce and really just varieties that you don't see at the grocery store at the farmers market.
Right.
And a lot of people, they just don't buy that stuff because they don't know what to do with it. And so I've
That's
been
me. That's exactly me. The stuff I look at, I'm like, wow, that looks really cool. I don't know what to do with it. That is really
so
interesting.
so right now I've been focusing on recipes that use those things. So it's really new. It's only like 3 months old. And like future plans, I've been prototyping a backpack to take to the farmers market.
That's a
Because
great
then you
idea.
can actually like carry all the stuff that you buy.
Yeah, yeah, exactly.
Um,
Instead of the little plastic
so
bags that the Amish guy gives you, the little
yeah,
paper bags and
or like
sacks.
the tote bags, because then all the weight is on one shoulder.
Yep.
See, when I was living in San Francisco, I was taking public transit to
Oh,
um,
okay.
to the farmers market because no one wants to drive in San Francisco.
Yeah, no, I understand that.
Um,
I'm in kind of nowhere, not I shouldn't say nowhere, uh rural Wisconsin, and there's a farmers market in town here. We have a large Amish community around, so they come in,
mhm,
and the food that they have that they've grown is so amazing. It's amazing.
yeah, yeah. So I was pretty spoiled in California with the year-round farmers markets,
Yeah.
but yeah. So eventually, I plan to make this backpack to sell.
Oh,
Um,
it's a great idea. So I'll give the website now. When I post this, I'll put links in there too, but it's theproducepack.com. And you've got seasonal recipes and market finds and the contact info. It's a beautiful website.
oh, thank you.
Did you put that
um,
together, or did you hire that
yes,
one out? It's
no, I
beautiful.
um, yeah, I'm that nerd who in like I guess it would have been starting in middle school for me. I felt like I got the internet like after everyone else in Silicon Valley.
Oh,
Like all my
really?
friends had the internet, but we
Sure.
didn't. And so when our house was finally connected, I was like, okay, well, I guess what people do here is they make websites. Turns out all they were doing was chatting,
Yeah.
but I was the one that went out and bought books on HTML and CSS
Oh, that's great. That's
and
fantastic.
learned how to do that kind of coding. So yeah, I do a bit of like everything.
Oh, that's cool. I mean, it's I'm a bit older. I For us, I was like the last of my friends that got cable TV. It was like 1981. So MTV was already out for a year, and I've been watching it at my friend's house, and I was missing out. And when I had MTV at home when I was a freshman in high school in 1982. All of a sudden I had MTV. It was like the world opened up. It's like, this is amazing. I have MTV. But I also worked for, on the side, though, I worked at a grocery store, and there was a lady that came to the grocery store that I just got to be friends with, carrying her bags out to the car. And, she was a really nice woman. And she had a computer business where there was no PowerPoint. So she made PowerPoint presentations for companies. So it was all like
Yeah, yeah,
DOS.
yeah.
So she's like, I'm swamped, and can you type it all? I'm like, well, I'm not a very good typist, but I can figure out. I took computer in school on an Apple IIe or whatever it was. And so I went over there, and she showed me how to do it, where we'd write like think about a page with like 4 sentences with a bullet point in each one. So we'd have to write a DOS line of code for the bullet point, and then for every sentence, and then for the space had to have a line of code. And so I was
Yeah,
doing this,
yeah.
and I actually really enjoyed it. And I was too dumb at the time to look at that as a career. It was just something I did, and she paid me really well. I think I made like $400 in the course of a weekend, a few,
That's
four
pretty
or
good.
5 times, because
Yeah.
she was making thousands on it. But she paid me $400, and I did it. And she's like, "Well, you're really good at this. You should pursue it." I'm like, I don't know. I want to play drums and be a rock and roll star. What an idiot. But it was amazing to me, like when the Macintosh computer came out. It was right around the time my mom was a school teacher, and she brought one home. It must have been 1985, I think 85, 86 when those came out. And this little Macintosh thing came out. It was like a $4,000 computer, with the 72 DPI screen, but you could do stuff on it, and it had one of these. And it was so amazing to watch
So
the
you want to know
progression of
something
that.
crazy?
Yeah.
So I went to the same high school as Steve Jobs did.
Really?
And
Oh,
my
that is crazy.
pre-calculus teacher was the same teacher that Steve Jobs did. So when you
Oh,
go to the
wow.
Smithsonian and you see the first Apple computer,
Hmm.
there are three Steves.
Yeah.
So there's Steve Jobs and Steve Wozniak.
Hmm.
There's the third Steve, Steve Headley,
Yeah.
and Headley was the teacher, the advisor.
No kidding.
He had one job his entire life, and it was teaching at Homestead High School. He taught
Wow.
pre-calculus and geometry.
Wow.
So yeah, he was probably the hardest teacher I've ever had. He
Wow.
had
It's incredible.
he never changed his final across the like 40 years of
Really?
teaching.
Did never evolve.
It was
It was that good.
it never changed. No one ever got 100% on it. I think the highest score was a 90%.
Wow.
It was 27 out of 30.
Think about if all the if all the teachers had been that good.
Oh yeah, well at the time I hated it
I'm
because
sure.
it was the only class in high school I got a B in.
Oh, no kidding.
And I am to this day very proud of that B. That was a hard-earned B.
It's a hard earned B. I've had
So
some classes like that where I'm like, I'll take the B in that one.
so yeah, so the class, it was pre-calculus, but we finished the textbook for pre-calculus in the fall semester. And so in the spring semester, he crammed in as much calculus as he possibly could.
Mhm.
So within a month of learning what a derivative was, we were doing triple integrals. It was insane.
Incredible. Incredible.
And so most of my math classes after that pre-calculus classes was a repeat. Yeah, that class was insane.
That's incredible. Well, with that, I think maybe we'll end the recording here. But I really, really appreciate you coming on, and I always appreciate
Yeah,
your posts on the network too, and continue to join us. And if you have anything interesting happening in the company for 3D printing or anything, go ahead and throw it in the throw up a post or something in the manufacturing group, because there's a lot of us in there. That's been growing. I think we're up to 26 or 28 people now, and I have a lot more content lined up for in there. So if there's things that other people that are in the group want to see, let me know, and I'll see if I can and facilitate that. But with that, we'll see you all next time, and thanks again for coming on.
Yeah, like I said, anytime, happy to chat.
Great, thanks.